Okay, video number 6. I was kind of just looking at my notes here and stuff, and I think what I want to do is I want to use the SPI 1 because I'm using the TX line already for SPI 0. I guess I could do that. So I could do SPI 0. It kind of starts here with the RX line. So this would be our SPI, and this is going to be RX. This is the SPI. This is the chip select line. The SPI SCK, the system clock for the SPI, and SPI TX. I'm looking clear over here in this column. So this is all SPI 0, but that's kind of what I want to do. Okay, so I need to add the next 4 things, and let me just remember those labels here. Let me get back into here. And I'm going to, again, do it manually, so I want to create a label. Oh, come on now. Now I want SPI RX, and I'm going to put that right on GPIO 4 or pin 6. Let me duplicate that and edit it. And this is the SPI chip select. We're going to duplicate that, edit it. This is the SPI SCK, the clock. And the last one, this one is the SPI TX, SPI TX. Okay. So there are the lines. Now, when I was setting up my connector, nothing's magic about this order, and it doesn't include the chip select in there also. So those will likely be whatever layout ends up being the most convenient, because I'm going to try to compress that down too. So I'm going to put them on the connector too, but I'm knowing in the back of my mind I may move them. So I just want to copy each of these. Oops. Sometimes I slip with the mouse. Okay. All the little circles are gone, all that. Oh, we never did assign a package to this. Let me assign a package. Now, on this board, when I actually do the layout, I want a standard header, but I'm going to put in a right angle one. But I need it right up next to the edge of the board. And then we'll label all the pins and stuff like that when we get to the layout. So I need the package though. So back over here, assign footprints, connector, generic pin header, 2.5 millimeter, 14. See most of that. 2.54 millimeter pin header, 1x14 P2.54 vertical. That's the one I want. Okay. Now, the other two that I want to make sure that we get in there are the analog to digital converter lines. And those are down here. We'll see how they work out. And let me go ahead and add those two in. So I want another label. And this is going to be ADC. We're going to use 0 and 1. Okay, so I want that to be ADC 0. You know, I can't spell either. Okay. ADC 0. That looks better. Okay. And then I want to duplicate that, and that's going to be ADC 1. Okay. Let me move copies of those over also. Duplicate. And I'm going to make the bottom two for the moment. And again, I may move these suckers around when it gets around to the actually doing the layout, but that'll be way easier. And I need 3 more I/O lines to go on here, and they're just GPIO. So I'm just going to grab whatever's conveniently close. You know, and I may start off with these 2 up here or 3 up here, but I'm also noticing that this is pin 39, pin 38, pin 37, 36, 35. So those would actually be in a line. You know, let's see where that goes. Let me just, as I said, it doesn't really matter at this point. And I think there's a way of doing this. Pin helpers. Let's try net label. I'm not sure I like that. Okay, let me just do it the old way. There's a way you can select all the pins and have it actually label them for you. But I don't do that many board layouts. Okay, there's 8, so I just need 3. Nine. 10. Okay. Duplicate, rotate. 8. Duplicate, rotate. 9. 10. Okay. Now I will likely stick another connector on the board just because you can't solder the pins on the processor. Okay, you can, but it's not something I would recommend. So I'll probably come back and add another connector. Just we'll see how the board lays out, just so I can reach the pins. And I might use one of those that's really hard to do anything with, which is like the 1.27 millimeter, which is 0.05 inch between pins. They're kind of a pain to actually use. But for the moment, I mean, let's just say this is what we want to do. So I'm going to come in here and I'm going to click this X, and I'm going to just mark the rest of them as not connected. Okay, so we should have pretty much everything we need. Let me run the error rule check. Always a good thing to run. Run it repeatedly, you know, and you get errors that says 0 errors, 0 warnings. It says 4 ignored tests. Global labels only appear once in the schematics. 4 connection points are joined together. Spice model issues assigned from that's fine. We'll just leave those in there. I don't think that'll, you know, you can edit ignored tests. Let's do that just to see what it says. You can pick, you know, spice models. We're not doing any spice simulations. It's kind of hard with a micro. Footprint things, you know, we're just going to leave that. Okay. So everything looks good. So close that. We're really pretty good with this at the moment. Let's go ahead and save it. Let's go back to our layout. And now up here, every time you make a change to the schematic, you must save it and then run the update PC board from schematic and say update and then close. And it added a connector. It added a big connector. Okay, let me just set that off to the side here. And you know, I've kind of moving things around from what I thought I was going to do anyway. So let me just move some of this stuff around because I know it's going to be a problem. Let me just go ahead and kind of scrap what we did earlier. Let's put those kind of together. Because the dominant thing on this board, size-wise, is this guy. And I'm going to put pin 1 to the left. Now, when we put these traces on the board, or the board outline, I had the snap set really large. And when I want this thing next to the edge of the board, I'm going to want it really pretty close. But it's really kind of nice to actually put it exactly where we want it. So I'm going to come here and I'm going to move it again. And I'm going to move it kind of sort of close to where I want it. And I think I can do it somewhere like there. Now the silk screen goes right off the edge of the board. I'm not going to worry about that too much. But let me see if I can actually hit that spot. If I just, again, put the cursor on the thing and hit the E key, this says that it's J3, it's the 1x14. It's not the pad, it's the whole thing. But I can specify the exact position that the board is in, that it goes to. So if I say, you know, 4.0, let me just go to 4.1 and 5 is not going to work. But let me do this here. Let me go to 5. Okay, so that's right on the edge of the board. So I mean, I got to go up again. Let me instead of doing 5, let's do 4.9. So I'm 1/10 of an inch from the center of the thing to the edge connector. And I'm going to grab a ruler. And because this one on the previous design worked really well. And I want to see, is that what I did? Yeah, I did 1/10 of an inch exactly between the edge of the board and the center. So this is at the on the XY coordinate 5, and this is 4.9. So I know exactly where it's going to be, and that is actually kind of convenient. Now, do I want the board to be exactly that dimension, and can I make it fit? That's going to be the other question. So if I wanted it to fit, I could take this, let me set my snap back big again to 0.1. And I can take this thing and I can say move it. 1, 2, 3, okay, that would be exactly fitting the board. That might be nice. Let me just do that. So let me delete this other trace out and redraw that edge cuts trace. And I want a line. Okay, I want to go from there to there. Now, I don't know if I can make it fit in this, but that's kind of what I want to do. I want to just kind of decide how big the board's going to be up front. Now, how tall it has to be to make everything fit, that's a separate issue. Okay, and we had said the VSys signal which comes right off the USB connector, is going to go to pin 1. And pin 1 is right here, VSys. You can see they're labeled for us. So I could take this USB connector now, and I could put it up here pretty close, but you know what? My grid's too big again. I need my grid back down to tiny so I can move it exactly where I want it. And the ground is going to be right there anyway, so I can put this thing right up against the edge. And you can see the edge in this silk screen. So let me just put it right up tight like that, because that'll work okay. Because here's VSys, which comes right out of these guys. Here's my ground, which is right there. The 3.3 is on a regulator, so that's actually separate. So I'm not going to worry about it too much, but that looks like it'll be close. So that's kind of what I want to go for. I don't know if I can make that vertical fit, and I'm not going to worry about it too hard yet. If I need to stretch it up, I will stretch it up. I mean, that's just the way we can work these things. So now I can start thinking about the regulators and power and stuff like that. So this D1. And I'm continually watching these lines. You can see where that has to connect. But I could put it clear up here, up next to the edge of the board. And then we already took these 4, and I could move them as a block. Like that. Now, the other thing to remember is this is all just on the top side of the board. We still have a bottom side that we can do things on, but we're not going to put parts on the bottom. You can, but don't. Okay. And then the labels, we're going to move all those around too before we get there. But that doesn't look too shabby. Okay. I need a regulator. This is our voltage regulator. Yeah, see, don't think I'm going to make it fit very well. Let me see. If I get this down pretty low, I know I need a couple of caps. Let me go back to schematic for a second. So I'm going to need C7 and C8. They go right beside that regulator. So let me go find C7 and C8. Oh, there they are. There's C7. There's C8. Okay. Now, I don't expect your board to be quite as tight as this one, especially if it's your first board. But I try to make it exciting for me too. So, okay, let's see here. Now, I'm watching the rat's nest lines, and there's that ground and the other signal that's right there. And, you know, I could do this either direction. But there's a ground that's down here also that I need to hit. So if I rotate this, it may not be as bad as it seems. Okay, let's do that. Okay, now the processor, you know, those pins look, very few of those traces walk over the top of each other. That may not be too bad. Let me think about this a little bit. I do need that memory chip though. Those all connect up there. And again, I've got the bottom side of the board to work with to get traces out. Now, with these pins as close as they are on the processor, I mean, the center to center on these pins is 0.4 millimeters, so that's tiny. So when you bring traces out, you really do need a little bit of space around there to work. I need a reset button. Oh, we do have a, I think I put the C6, I put right there from power to ground at the memory chip. And I think I want to keep it close to the memory chip. So I do need that, the C6, that's this one here. And we rotate this around. Again, I'm ignoring labels because they really won't, you know, we'll move some of them around. We'll make sure everything fits. Okay. Still thinking about how some of this stuff's going to work. You know, it'll be close. Crystal, move. Okay. Now there's the crystal. See, that's the wrong, you know, okay. So what I've spotted is I've got a problem. The ground is on 2 and 3. And my crystal's actually, the signal's on 1 and 3, and the grounds are on 2 and 4. So I've got to go fix that. So let's go fix that, and then I'll fix the video. So save the work. You don't want to lose anything. Back to schematic. Yeah, I picked the wrong one. Let me change the package on that one. Let me delete this. And then let me add a crystal. Crystal, 4-pin. I can't see the labels. 4-pin crystal, grounds on pins 2 and 4, small symbol. See, I grabbed the wrong one. That one's the one I needed. Okay. That looks better. So let me put that there. Now let me edit that one, get rid of and change that to, this is 12 megahertz. And let me move that. Let me put it up here. And let me move this guy down there. Okay, let me save that, go back to the layout, and then re-import this. And then, oh, I understand. It has a problem because I did not package. Okay. Crystal. This is the make sure I grab the right one. Seco Epson FA238, Seco Epson 238, 4-pin, 3.2 by 2.5. That one. Here we go. Okay. Save. Back to layout. Update from this. Update PC board. No errors. Close. Okay, so there's the new one. Why did it not delete the old one? Okay, so this one goes away. Now, that looks better. Okay, so, and I'm trying to something still isn't right. Oh, I see. Okay. We got a resistor in there. I was looking at the rat's nest lines, and we have a resistor and a couple of capacitors that go with that. Let me just move them down into the area so they don't cause the rat's nest to go into funky places. Okay. And then the schematic shows that we've got R3 that is included in that whole thing. R3 looks like, is that R3? That's R3. Okay. So now we can bring it back down here. Now the crystal lines need to be really short too. Okay. I think I've talked long enough. Okay, so you know, I'm thinking I may be a bit too aggressive on getting that to fit to the 14-pin connector, and if I have to make the board longer, you know, I might just go ahead and make it a 16-pin connector. You know, so there's nothing hurting me from doing that or stopping me at this point. I haven't done any traces; it won't cause any extra. I kind of like the way the board is looking out at the top, so if I can get it to fit in here without stretching anything too much, that might not be too bad. So we may just go to a 16-pin connector, but you know, we'll do that on the next run. Okay, so let me save this and then we'll go from there. Okay, end of video.